I'm looking for the scikit-learn linearregression model attribute that always gives me the y-intercept. That's the point where the line crosses the y-axis. Think of it as the starting point of your line. This is it. Model intercept underscore is the attribute that directly provides the y-intercept. It's a single number. The y-intercept, the point where the regression line crosses the vertical y-axis. It's a crucial part of the equation for a line. Y equals mx plus c, where c is the intercept. This attribute gives the slope of the line. In simple terms, it tells you how steep the line is. It's not the y-intercept. This gives the r-squared value, a measure of how well the line fits your data. It's a goodness of fit measure, not the y-intercept itself. This simply counts how many input variables linearregression used when it was trained. Not the y-intercept. This tells you how many predictor variables, the x values, were included in the model. It doesn't tell you anything about the y-intercept. This is a statistical measure of how well the model fits the data. It is a value between 0 and 1, with values closer to 1 indicating a better fit. It is not the y-intercept. I'm going to test you on the linearregression model attributes in scikit-learn. Let's find out if you know how to get the y-intercept. The slope. This describes the steepness and direction of the line in your model. In the equation y equals mx plus c, m is the slope. This is a quiz about understanding different attributes of the linearregression model in the Sklearn library. I'll test your knowledge of which attributes give you specific information about the model's fit. Get ready. Let's say you have built a simple linear regression model using Sklearn with one predictor variable. I want you to identify which attribute will always provide a single number representing the y-intercept of your fitted regression line. The y-intercept is the point where the regression line crosses the y-axis. Think carefully. This is the correct answer. Yes. The backquote model intercept underscore backquote attribute directly stores the y-intercept value of the fitted regression line. In the equation of a line, y equals mx plus c, c represents the y-intercept. This attribute always gives you that single value you need. This attribute holds the slope of the line, the m, in y equals mx plus c. In a simple linear regression with one predictor, it's a single value, but it's the slope, not the intercept. Remember to distinguish between the slope and the intercept. This is a method, not an attribute. It returns the r-squared value, which measures how well your model fits the data. It doesn't directly give you the y-intercept. This attribute tells you the number of predictor variables, features, you used to build the model. It has nothing to do with the line's intercept. I'm explaining scikit-learn, a popular Python library for machine learning. Specifically, I'll focus on attributes of the linear regression model. Think of attributes as information the model provides after it learns from your data. This is a multiple-choice question testing your knowledge of linear regression attributes in scikit-learn. Get ready to show off your skills. This tells you how well your model fits the data. It's like a grade. A higher score means a better fit. It's not related to the y-intercept. This attribute tells you how many predictor variables your model used. For example, if you predict house prices based on size and location, this will be 2. It's not the y-intercept, though. This gives you the slope of your regression line. It shows how much the target variable changes when a predictor variable changes by 1 unit. Important. It's not the y-intercept. This is the y-intercept, where your regression line crosses the y-axis. In the equation of a line, y equals mx plus c. This is the c. This is the key. This section introduces the core concept, identifying the intercept in a linear regression model using the scikit-learn library in Python. I'll explain how to find that key value that tells us where the regression line crosses the y-axis. This is a multiple-choice question, which means I will provide different options related to attributes that might contain the intercept, and you'll have to select the correct one. Think of it as a little quiz to test your understanding. We're using a popular machine learning tool, scikit-learn's linear regression, to find a line of best fit. This problem uses a simple linear regression with one predictor variable, one input, making the model easy to understand. This attribute gives the slope of the regression line. In simple words, it tells you how steep the line is. It is not the intercept. This is the correct answer. This attribute gives the y-intercept. That's where the regression line crosses the y-axis. In the equation of a line, y equals mx plus c. This is the c. This is a method to get r squared. R squared tells us how well the line fits the data. It is a measure of goodness of fit, not a specific point on the line like the intercept. This tells us the number of input features, variables, used in the model. It is related to the model's setup, not the specific line of best fit itself. These are the options to choose from to answer the question. I have already reviewed each option. This section tells us what information we can extract from the fitted model and that we need to know model attributes to solve this problem. Understanding these attributes is key to solving the quiz. I'm looking for the scikit-learn linear regression model attribute that always gives me the y-intercept. The y-intercept is where the line crosses the y-axis when x is 0. Think of it as the starting point of your line. This is it. Model, intercept underscore, is the attribute that directly stores the y-intercept value. It always holds a single number representing that point on the y-axis. This attribute gives the slope of the regression line, not the intercept. The slope shows how much y changes for every 1 unit change in x. It's not what we are looking for here. This is a method, not an attribute, and it returns the r-squared value. R-squared measures how well the line fits the data, not where the line starts on the y-axis. So this is not the correct answer. This attribute tells me how many predictor variables, x values, I used to fit the model. It's not related to the y-intercept. I'm focusing on attributes of the scikit-learn linear regression model. These attributes provide information about the fitted linear regression model. We'll look at what each attribute tells us. This is a multiple-choice question testing your understanding of those scikit-learn linear regression model attributes. The question is designed to check if you know how to get the y-intercept from the model. Imagine you've used scikit-learn's linear regression to build a model that predicts a value based on another value. A simple linear regression. Now let's figure out which attribute gives the y-intercept value, the point where the line crosses the y-axis. This attribute, model, gives you the slope of the line. Think of it as the steepness of the line. In a simple linear regression with one predictor variable, you'll get one value, but that's the slope, not the intercept. This is the key. Model. Intercept gives you the y-intercept. That's where the line crosses the y-axis. This is the value we want. The model. Score, method gives you the r-squared value. This is a measure of how well your model fits your data. It doesn't tell us about the intercept. Model. N features in tells you how many predictor variables, features, you used to build the model. It has nothing to do with the line's position on the graph. I'm using scikit-learn, a powerful Python library for machine learning. Specifically, I'm focusing on the linear regression model, which helps me build a linear equation to predict values. This model has several interesting attributes that I can explore after fitting it to data. This is a multiple-choice question testing your understanding of the linear regression model in scikit-learn. I want to know which attribute gives me the y-intercept. That's the point where the line crosses the y-axis of my fitted regression line. This attribute, model, intercept directly provides the y-intercept. It's a single number representing where my regression line hits the vertical axis. That's exactly what I need. The model. Score, method calculates r-squared, which tells me how well the line fits my data, not the actual intercept. The model. Attribute gives me the slopes of my line, how steep it is. It's not the intercept. The model. N features in attribute tells me the number of predictor variables, features, I used in my model, which is not related to the intercept of the regression line. The intercept is the point where the line crosses the y-axis. It's a crucial part of the equation of a line, y equals mix plus c, where c is the intercept. In simpler terms, imagine a line on a graph. The intercept is where that line touches the vertical, y-axis. It's one of the two key ingredients that define the line, the other one being the slope. I've got it. The correct answer is B, backquote model. Intercept underscore backquote, because it directly gives the y-intercept of my fitted linear regression model. I'm ready for the next challenge.